So let's go through some of the steps you might use to get a titration curve going. So you're probably given some constant, something like a Ka, acid concentration, an acid amount, and a base concentration, so OH. Okay, these are just letters. They don't really mean a whole heck of a lot as far as Excel is concerned. Now, each of these are going to have different values that we put in that I want to just use. So let's say that my Ka was 2.76 times 10 to the minus 5. So the way that I would put that in then here is 2.76 E minus 5, not Xe, E minus 5. All right, and then the computer makes that a capital E minus 5. So that is times 10 to the minus 5 as far as the computer is concerned, and you can see that right there. My concentration was 0.120. The amount that I was given was 25 milliliters, and I'm going to do all of this in liters. So 0.025, and my OH concentration is 0.012. Okay, those are my constants. So the next thing we want to do is get our volumes put in. So I want volume increments of 1 mil. So let me just say this is a volume of OH. Now what I really want to do is I want to do this in units of liters. So 1 milliliter is going to be more than this, right? So I'm starting at 0, and then to that I want to add, so I'm going to write in equals this plus 0.001. Okay, so that means that this cell is 1,000th more than that cell. So that's 1 milliliter. And if I take this little thing here and I drag it down, it becomes 002 because it is 1 plus the cell above it. So that's an easy way for us to go through and do this. And I can take that all the way down to, I think it's about here. Okay, so that's how I can get 50 milliliters put in very easily. So the next thing I want to get is moles of HA, and that's already written in here. The way that I calculate moles of HA is going to be it's equal to my original concentration of that, so that's what this is, multiplied by the amount that I have. Okay, and that's the number that I should have. Now once this reaction starts, it's going to be equal to the amount that I put in there, sorry, the original concentration, times the amount that I put in. And then I'm going to be taking away the the concentration of base times the number of moles that I put in there. Okay, so my moles of original acid minus the amount of moles of base that I put in is going to give me this. Great, that's exactly what I expect. This is 0.012, yeah, this is less than that. So now if I take this and I scroll it down a little bit, all of a sudden it becomes zeros, and that's not what's supposed to happen. And that's because basically every time I go down, you might see that these numbers here are increasing. So I need to keep my constant values in here, constant. So the constant values that I put in here, B2, that is my concentration. So I want to keep that constant. I'm going to put a $sign in front of the B, call it $sign in front of the 2. That's going to lock it into place. Times B3, the amount. So $sign in front of the B, $sign in front of the 3. My OH concentration, B4, I'm going to lock that in as well, so my OH concentration doesn't change. The only thing that is going to change is the amount that I'm putting in here. So this number here, C3, this cell, here it's 0.001, next it'll be 0.002, so we're in good shape. That number didn't change, but this number will when I pull this down. See? And it keeps on going down by the same amount. Okay, so I'm going to do this all the way down to here at 25 where it becomes 0. And this becomes a different problem at 25. Okay, so we'll move on to the next little bit there. So the first thing I want to do is realize that from here on out, after this point, I have no more moles of acid. So I'm just going to put in a 0 here. And then I'm going to grab this and sort of drag that down because I have no more moles of HA left. And now I want to keep track of moles of A minus. Okay, so this is at the beginning, that's 0. And now it's going to be equal to basically, I make 1 mole of this for every bit that I start with, so that's going to be equal to my OH concentration times the amount that I added. Okay, so 0.00012. And again, I want to keep this number here constant, so B4 gets dollar signs in front of the B and the 4. And what that does is that every time I pull this down, it's going to use B4 instead of going on to B5, B6, and so on. Okay, so at this point, you can see how many moles of this stuff I've made. And then here, I've got pretty much, that's all I've got. Okay, and now at this point, I'm really not making any more. That's the original concentration that I have. So it's going to be zeros on down. Not 0, that's not the concentration. It's going to be equal to 0.003 number of moles the whole way down. Okay, so that is how I get my moles of A minus. So we're going to get the pH in a few different steps here, and the first step that we're going to do to get pH is, the initial pH of a solution that has, this concentration of an acid and this Ka. That is going to be equal to a formula. Hopefully, it's a formula that you've worked with before. You should know it, but it's basically going to be equal to the Ka times the concentration of the acid that we're working with. Now, it's those things, but it's also the square root of that. So I'm going to, in front of this, write SQRT, and in parentheses put here and there. So I'm taking the square root of those things. And then it's going to be the negative log of that to make it a pH. When I put that in there, I get 2.739995, and that is just way too many significant figures. So if I click here on the Home tab, and I click this button here, I want to go back. So I really only have 2 significant figures past the decimal point. Okay, so that's how we get for the initial pH. It's going to be different for all the ones going on after that. All right? So now we're ready to get the pH at the places where we're in the buffering situation. So that is the Henderson-Hasselbalch equation. So that's equal to the negative log of the pKa, of the Ka, which is this. So I'll just put that in there. And it's going to be a constant, so I'm going to want to have, my dollar signs in there. And then we're going to add to that the log of our moles of base divided by our moles of acid. And that's it. Our pH has increased here a little bit, and we're going to go all the way down to here. The one right before where we run out of base, because that's a different problem entirely. Now again, I just want 2 places past the decimal, so like that should do it. Okay, so that's how we enter the Henderson-Hasselbalch equation and do a whole bunch of different calculations all at the same time. So now that I'm here at the equivalence point, I need to remember that my pH is going to be based solely on the amount of conjugate base that I have. So this is the amount of conjugate base that I have from this point forward. So that's the number of moles that I have there. So this is going to be equal to Kw, which is 1 times 10 to the minus 14, divided by my Ka, which is this. Okay, so that's that, and then that's going to be multiplied by the concentration of my base, so that's the concentration of my base, and that is divided by the sum of these 2 numbers here, the amount of base that I added, so I need new parentheses, base that I added, plus the amount of acid that I started with, so basically 50 milliliters, total of 50. All right, so that is my concentration times that. Cool. Now it's going to be the square root, SQRT, of that. So another parentheses there to get that whole thing in there. And it's going to be the negative log of that. Another parentheses at the end of there. That's my POH. And then so what I really need to do is I need to take 14 minus that whole thing. And we're there. and I have a pH of 8.67. That means that when I have nothing but that conjugate base there, my pH jumps quite a bit. Okay, and that is the pH just at that one point. So now what we're going to do is we're going to figure out the pH when really hydroxide is the only thing I have left. But the question is how much hydroxide. So this cell is going to be equal to the concentration of hydroxide that I've added times the amount that I've added minus all of the acid that it's reacted with, which is the concentration times the amount. Okay, and this is a group, so I'm going to put parentheses around this. Now, the other thing I'm going to do is everywhere where there's a B, get the $sign so that I'm going to use these constants over and over again, and I don't really want any trouble for it. And that is divided by my new volume, which is the sum of the base that I put in there plus the acid that I started with, which is this. And again, I want the $signs in front of the B and the 3. Okay, so that's my new concentration. I need to take the negative log of that. But this will be the pOH, and I'm not interested in that. I'm interested in the pH, so I need to take that number and subtract it from 14. So 14 minus this entire group. And there we go, 11.37 is about what I was expecting. So I'll just drag this on down. There we go. Now I've got both my columns there. So I've got my now I've got my volume column all filled out and my pH column all filled out. So at this point, making the graph is actually pretty easy. What I want to do is I want to highlight column C. I'll hold the control button down and then highlight column F. And I'm going to click on Insert. And we come over here to Charts. And I want this one, the one with the curvy lines between. The straight one's not that different, but the curvy one's what I want. Cool. There's my graph. It's exactly what I'm looking for. And the really cool thing about something like this is if I change the Ka to, let's say, 5.67 times 10 to the minus 9, it will automatically change all of this for me. Look at the drastic change that we see there. So this is fairly powerful. Now, obviously, it's not a calculator. There's some other math we'd have to put into this to make that happen, but this is pretty good for what we needed to do. If you want to put in axis labels, you click on this X right here, click on axis titles, and then you can type in your axis titles here. You know, volume OH in milliliters. This one here is pH, and you're off to the races. Change the title here by putting in a good title, and you're set. There you go. Not so bad, huh?